Alright guys, I'd like to work another projectile motion problem for you. This one says a projectile is shot from the ground at an angle of 36.9 degrees above the horizontal with a speed of 15 meters per second. Find the following. So we'll start with Vx and Vy. So Vx is the horizontal component of velocity, so I'll redraw this. We have V initial, which is 15. We have Vx. And we have Vy here, the angle, 36.9 degrees. Recalling SOHCAHTOA, for Vx, you will notice that we are using the adjacent and hypotenuse, so that's going to be cosine. So that's going to be 15 cosine of 36.9 degrees. Which is 12 meters per second. And for Vy, we are dealing with opposite and hypotenuse. So we will be using sine, so that is 15 sine of 36.9 degrees, which is 9 meters per second. So here's Vy, here's Vx. Okay. For part B, total time in air, I'm going to do my best to stay organized, so I'm going to make a chart before I start part B, and I'm going to put as much information as I possibly can. So here's X, here's Y, here's Vx, dx, and t. Vx is 12. In Y, I have final, initial, acceleration, displacement, and time. Initial velocity in Y we found was 9. Now, let's go back to our picture for a moment. So I need total time in air, but if I'm careful, at the top of its motion, I know Vy is equal to 0. And I know, guys, that this here is half the motion. And as a result, also half the time. Now, at the top, the projectile is still moving. Okay, it has speed Vx, right? But if I just use the vertical information, that's not needed. All right, so if I look at half of the motion here, then what I meant to write here, guys, this 9 meters per second is initial velocity. I put it where final velocity is. This is 0. This is negative 9.8. Displacement, I don't know. Time I would like to begin with. Based on the variables I have, I can use the first equation, which says V final equals V initial plus AT. So the time for the projectile to go through half of its motion would be final minus initial over A. So that's going to be 0 minus 9 over negative 9.8, which is 0.92 seconds. So this value here, 0.92 seconds. Now, to get total time, that is the total time of motion. If I have half the time, the total time is just 2 times the half time. So that is 2 times 0.92. 1.84 seconds. Like so. Right, that's part B out of the way. Part C says horizontal range. So For part C, looking at my x column, I know the initial velocity in the horizontal direction is 12 meters per second. That doesn't change because there's no acceleration. I know the total time of motion is 1.84 seconds, so I can easily get horizontal distance. So Vx is equal to dx divided by time. Dx then is Vx times time. So that is going to be 12 times 1.84, which is 22.08 meters. Like so. Part D, this is what is the maximum height. So for part D, we need to look at the vertical information again. So here is y, vf, vo, a, d, and t. Initially, vertically, the projectile was moving at 9. At the top, the final velocity is 0, acceleration is negative 9.8, and the time we found to be 0.92 seconds. So to get displacement, I'm going to use the second equation. Plug numbers in. So we have 9 times 0.92 plus 1/2 times negative 9.8 times 0.92 squared, giving us we get 4.13 meters here. Like so. And lastly, for part E, part E is impact velocity. We could do all the math, we could draw the triangle, we could solve it, but if we're very careful, we don't have to do that. Here's what I know. I know the initial velocity was 15 meters per second at an angle of 36.9 degrees to the horizontal. I also know the projectile was fired over level ground. So, some facts that I'm going to apply here is, first of all, the horizontal velocity does not change because there's no acceleration in the x direction. So Vx at the beginning of the problem, which was 12 meters per second, is constant throughout. So this is 12 meters per second. I can also apply the fact that for vertical motion, assuming level ground, time up equals time down, and therefore V initial is equal to minus V final. So the final y velocity here is negative of the initial velocity, which is 9 meters per second, but negative. This is impact velocity. This is theta. I have the same triangle that I began with. The only difference is it's oriented below the horizontal rather than above. So I can write my impact velocity as 15 meters per second. That would be found by doing Pythagorean theorem at an angle of 36.9 degrees south of east, or you could say below positive x-axis as well. I hope this is helpful, guys. Thanks.